This video is about percent error. We need to determine the accuracy of our measurements, and on your table T of your reference table, there's a formula to do just that. It's a measured value that you would take in a lab minus the accepted value that you would find in a reference table or online reputable device or textbook, divided by that same accepted value. Now the thing is, a percent error should always be positive, so what I think this is lacking is the absolute value. So there should probably be absolute value bars, and if you want to add that to your reference table, you're more than welcome to do that. And because it's an absolute value, you actually can subtract in either order, measured value minus accepted, or accepted minus measured. So generally when I do that, I make sure that I do big minus small, so it comes out positive. But what you can't do is put measured value in the denominator. It has to be the accepted value. The way I consider this in an analogy is when you do your top 20s and you want to figure out what your percent score is, you do your accepted value in the bottom, right? 18 out of accepted 20, right? So the number that you should get has to go onto the denominator, right? So this is on table T of your reference table. Please take a look. So let's try an example. Working in a laboratory, a student finds the density of a pure piece of aluminum at 2.85 grams per centimeter cubed, and the accepted value for the density of that aluminum on table S is 2.699 grams per centimeter cubed. We want to know how close we were to that right answer. So we're going to take the two numbers, 2.85 being the one that you measured in the lab and placing that first, and then 2.699 being the accepted value labeled in the question. We'll subtract them and divide by the 2.699 because that is the accepted value, and I get an answer when I multiply by 100 of, where am I? Oh, 5.59%. What you don't want to do, as you can see in the last calculation, is they divided by 2.85, the measured value, and they didn't get quite the same number, 5.30. That is not the answer. You always want to divide by the accepted value of your number. So let's try that again. The accepted value for the volume of a gas is 22.4 liters. In a lab experiment, the student determines it to be 24.8 liters. We want to know how wrong their answer is. So we'll subtract the measured value minus the accepted value. In this case, you notice that I actually did them in that right order. And I divided by 22.4 because it has to be the accepted value on the bottom. Times 100, and I got the same, when you subtract, you get 0.4, and then you divide that by 22.4. I got 10.7%. You only have to show the setup in your answer. You don't have to show the middle step. Now I wanted to see if you can do it. In an experiment, a student found the percent of oxygen in a sample of KClO3 was 42.3%. If the accepted value is 39.3%, what's the experimental percent error? Now that you put your answer into the Edpuzzle question, let's see if you got it right. I would subtract the two values given, and I would have to divide by the 39.3 because it was labeled the accepted value. We times by 100. If you want to reduce, you're more than welcome to reduce, and our answer is 7.63%. And I think that's it.